A persistent legend claims that Victorian black mourning dresses were laced with lethal doses of arsenic, slowly killing the widows who wore them. There is a factual basis for this historical fear. Period journals detail how women in these heavily veiled gowns suffered from severe skin rashes, respiratory issues, and even blindness. These records are so documented that modern museum conservators must treat 19th century textiles as hazardous materials, handling them with nitrile gloves and lab coats to avoid chemical exposure. However, the chemistry of the era suggests we might be convicting the wrong poison. When modern forensic science examines these iconic black dresses, the arsenic myth begins to unravel. The cultural catalyst for this wardrobe was Queen Victoria. After the death of Prince Albert in 1861, she wore black for the remaining 40 years of her reign, establishing a rigid sartorial law that radiated across the British Empire. Etiquette manuals codified this grease into a strict timetable. For a widow, first mourning required being enveloped in yards of black crape, a crimped silk explicitly designed to absorb light and project profound sorrow. To meet the demand for this specific fabric, manufacturers like Samuel Courtauld and Company centralized production in factories that employed over 3,000 workers by the end of the century. They replaced artisanal dyers with steam-powered looms and massive chemical vats to produce millions of yards of black silk. This industrial process was chemically intensive. Raw silk was degummed in acid baths of hydrochloric or sulfuric acid, then passed through heated engraved rollers to permanently emboss the fabric with its signature scratchy, rigid texture. The strict social rules of Victorian bereavement aligned perfectly with the birth of unregulated industrial chemistry, creating a production cycle driven entirely by mortality. Modern museum professionals now use non-destructive tools like X-ray fluorescence to identify the precise chemical signatures left behind by 19th century dyers, without damaging the fragile textiles. This forensic analysis shows that tests on mourning crape reveal zero evidence of arsenic. Producing black textiles in the Victorian era relied on an entirely different chemical pathway. The standard method combined natural logwood with heavy metal mordants. To lock in color, manufacturers used iron or highly toxic chrome. These metals were physically corrosive. Over time, they oxidize and catalyze the breakdown of silk proteins. This dye rot causes the fabric to shatter. The painful rashes suffered by widows were not caused by arsenic. They were allergic reactions to the acidic residues, chrome mordants, and harsh shellac sizing shedding from the stiffening fabric as it degraded. While the mourning dress was physically irritating and prone to self-destruction, it was chemically distinct from the arsenic hazards used elsewhere in the wardrobe. Arsenic was a pervasive hazard in Victorian fashion, but it was hiding in vibrant, brilliant colors. The most notorious was emerald green, a pigment made of copper acetoarsenate. This was used to dye voluminous muslin ball gowns and dust artificial floral wreaths, effectively coating consumer goods in raw arsenic powder. Recent findings in 2026 have expanded our understanding of these risks. Because early synthetic dyes, like magenta, utilized arsenic acid as an oxidizing agent, even bright pink and purple textiles from the 1860s often harbored dangerous levels of arsenic contamination. While affluent wearers occasionally suffered from these colors, the most acute toxicological burden was localized in the unventilated workshops where these goods were made. In 1861, a 19-year-old worker named Mathilde Schwerer died in agony after inhaling and ingesting green arsenic powder while fluffing artificial leaves. Medical reports noted her eyes and fingernails had turned green before she succumbed to convulsions and organ failure. The actual human cost of the era's aesthetic revolution was borne by impoverished laborers, not the consumers in the drawing room. Arsenic was only one component of a broader, unregulated chemical expansion in the textile industry. To mass-produce the era's new synthetic dyes, factories required nitrobenzene, a pale yellow, oily liquid known as oil of myrrhine. Workers exposed to nitrobenzene vapors suffered from acute blood poisoning. The chemical destroyed the red blood cells' ability to carry oxygen, causing victims' lips and skin to turn a ghostly blue before they collapsed from neurological failure. This flowchart illustrates the stark divide in safety. On the factory floor, workers faced severe, systemic exposure to volatile buzz. By the time those chemicals reached the consumer in a finished, weeping veil, the risk was buffered and localized, usually resulting in non-lethal skin irritation. The manufacturing of Victorian mourning fashion relied on this hidden geography of risk, where the respectability of the elite was directly subsidized by the health of the working class. The death toll in these factories eventually triggered a response from the medical community. Public health advocates and toxicologists began aggressive campaigns to link industrial chemicals to the illnesses seen in workers. Using early microscopic forensic tests, scientists like Dr. Alfred Swain Taylor conclusively demonstrated the toxicity of these consumer products, bringing the realities of chemical poisoning into public consciousness. This advocacy led to the Public Health Act of 1875 and the Factory and Workshop Act of 1878. These laws mandated better ventilation and established the first compulsory regulations for industrial manufacturing in Britain. These Victorian efforts to regulate aniline dyes and heavy metals established the protocol of investigating chemical impacts before they reach the consumer. Those foundational standards continue to guide regulatory bodies today as they evaluate the health impacts of modern microplastics and perfluorinated chemicals in our own clothing. Victorian mourning fashion serves as a historical case study in how technological innovation can outpace safety. The resulting legislation proves that aesthetic desire and industrial efficiency must always be balanced by rigorous scientific oversight.